Jonathan. And now we're going to turn to our distinguished lecture for 2012, given by Richard Klein. Richard G. Klein is the Ann T. and Robert M. Bass Professor and Professor of Anthropology and Biology in the School of Humanities and Sciences at Stanford University. Professor Klein received his bachelor's degree from the University of Michigan before moving on for his MA and PhD degrees at the University of Chicago. After completing his doctorate, Professor Klein taught at the University of Wisconsin-Milwaukee, Northwestern University, and the University of Chicago before moving on to Stanford University in 1993. He has served on numerous editorial and advisory boards and has edited the Journal of Archaeological Science since 1981. Professor Klein co-chairs the Grants Committee of the LSB Leakey Foundation and is a member of both the American Academy of Arts and Sciences and the National Academy of Sciences. Professor Klein's research focuses on the archaeological and fossil evidence for the evolution of human behavior. He's conducted field work in Spain and especially in South Africa, where he's conducted field work since 1969. Searching for evidence of the behavioral changes that allowed anatomically modern humans to spread out of Africa into Eurasia, where they eventually overwhelmed and replaced the Neanderthals and other archaic species. Professor Klein is perhaps best known for his provocative theory concerning the evolution of behavioral modernity. Behavioral modernity, which involves human behavior based on symbolic thought and cultural creativity, evolved in a relatively short period of time, between about 50,000 and 40,000 years ago, during the Upper Paleolithic. Further, he proposes that behavioral modernity is likely the result of one or more genetic mutations, possibly that enable better language skills and communication, that gave anatomically modern humans an advantage evolutionarily over Neanderthals and other archaic species. Thus, Professor Klein's research encompasses two of the most central questions to anthropology, both what makes us human and what does it mean to be human. It's therefore my pleasure to introduce the 2012 General Anthropology Division's distinguished lecturer, Richard Klein, speaking on modern humans.
Well, I want to thank Chris for inviting me, and people were here coming to hear me. It's a little strange for me. I don't want to take time with this, but I'm not in the anthropology department anymore. I was once, and perhaps still have an biology department. I'm going to tell you something about how anthropology has changed from Paleolithic until the present. Anyway, what I want to talk to you about today is the origins of fully modern humans, people who look and act basically as we do. So anybody that might walk into the room, sit down, you glance at them, that maybe you glance, they wouldn't really probably attract much attention. That's probably been true of people who've been on the planet for the last 40 or 50,000 years. Before that, it would have been different. There were people who looked quite different from us, and I think just about everybody behaved in quite a different way from us. So I'll elaborate a little bit on that. I thought to put this in context, I would give you the entire sweep of human evolution very quickly here. This is what's called a phylogenetic tree. It says family tree, actually. Today we think of humans, creatures we call humans, the species, as a tribe in zoological terms rather than a family. The family still works out okay. How do we identify humanity in the broad sense, the earliest humans and the ones that succeeded them? Well, the conventional wisdom is that the earliest people, earliest humans, earliest hominines is the proper term, I suppose, were distinguished from the line that led to the chimpanzee, our closest living relative, by bipedalism. That while the ancestors of the chimpanzees continued to be basically quadrupedal, four-legged, humans, ancestral humans, the first ones got up on two legs and began to move around habitually that way. That probably happened sometime between 8 and 5 million years ago. It's difficult to be precise. The estimate is based on the degree of genetic divergence between us and chimpanzees rather than on the fossil record. There are some fossils back there at about 6 million years. You can see this chart here. On the left side, there's time in millions of years, MA. And you can see going down to about 6. There are some species back there at 6, maybe even a little bit before, let's say between 7 and 5, that have been regarded as hominines, that is, bipedal ancestors to later people. But in fact, the oldest really good anatomical evidence for bipedalism is only at about 4.1, 4.2 million years. I've indicated it with an arrow here. So the species Australopithecus onamensis, where we have at least one bone that indicates unequivocally that the species was bipedal. Probably it will turn out that some of these earlier things were bipedal too, and there are advocates for them right now. And then you see there's a proliferation of species afterwards. The human family tree has gotten very bushy. My main concern here today is not to talk about these earlier species, but just about mainly about the ones, let's see if I can get this pointer working. Yes, there it is. Okay, I'm going to be talking about species at the very top of the diagram. Ones, oops, I didn't need to do that. Ones that existed as recently as 50,000 years ago, and that, and of course in our own case, they continue to exist today. If you could look at this thing with a ruler, you'd see that the species in the middle, called Homo sapiens, goes right on up to 0 millions of years ago. The other two species on either side, the Neanderthals and Homo erectus, go up to about 50,000 years ago. I realize that's not perceptible on this chart, but that's what it's supposed to show. Now, if we move back just a little bit in time, you see, I'm reluctant to, let's see if I can do this without changing slides. There's a species there called Homo ergaster, which is probably the first human species to leave Africa. Everything else you see on the chart prior to Homo ergaster was confined to Africa. The date of emergence is maybe a little bit debatable, but it's somewhere probably about 1.7, 1.8 million years ago. Once Homo ergaster left Africa, it spread to Eurasia. Of course, there were still people in Africa. It wasn't all Homo ergasters that left. We get divergent evolutionary pathways in different places, natural selection, genetic drift, and so forth, resulting in the emergence of distinct human types, which I've called here species. The first to diverge, if you accept what this chart says, and this is just a hypothesis, this chart, I think it's not far from the truth, it's a lot closer to the truth than ones I would have done, anybody I think would have done 10 or 15 years ago, and hopefully there'll be ones in the next 10 or 15 years that'll be that much closer. But it's a reasonable approximation of probably what happened. And the first species to diverge after Homo ergaster left Africa is what I'm calling here Homo erectus. You see it in the upper right part of the diagram. That's the people who moved off from the initial emergence of Homo ergaster and established themselves in the Far East. I actually think there were two versions of Homo erectus, but this chart shows it as if there were one. Homo erectus is known popularly in two different kinds. There's Peking man, Beijing man, and Java man. And as far as we know, Homo erectus persisted in the Far East, in Eastern Asia, until about 50,000 years ago, when it was supplanted by Homo sapiens spreading from Africa. That's the heart of the story that I want to tell today, about the expansion of Homo sapiens out of Africa. And then, the way I've drawn this, Homo ergaster evolves in the West into something called Homo heidelbergensis, which was present in both Africa and in Europe, while Homo erectus was in the Far East. And then Homo heidelbergensis was ancestral in Africa to Homo sapiens, that's us, and Homo neanderthalensis in Europe. Now, obviously only Homo sapiens survived. So what I want to talk to you about today is why that is. What happened to these other species? Why is only one human species still around? Okay. First point, I better not spend much time on this because I think I only have 2 hours, right? So I'll keep this brief. For people who may or may not, I don't know, maybe it's not appropriate for this audience, you may know about what distinguishes various fossil humans from us, from each other. We generally rely more on the skull than anything else. This is just to show that it's not difficult to do. On the left here, you have Cro-Magnon, in fact, early modern European, that is one of the Cro-Magnon skulls. One was called Cro-Magnon 1. And on the right, a Neanderthal. The Cro-Magnon lived about 30,000 years ago in Europe. The Neanderthal also lived in Europe at a place called La Chapelle-au-Saint, died there anyway, buried there, about 70,000 years ago. And you can see they're quite different. I've just noted some characteristics that are distinguishing between them. So in us and in this Cro-Magnon, the face is tucked in underneath the forepart of the brain, relatively short and flat. In the Neanderthals, the face protrudes far forwards, out in front of the forepart of the brain. It's very long, particularly protrudes forward along the midline. So if you want to be a Neanderthal and your features were totally plastic, you put your fingers on your nose and pull out 2 inches. You'd look something like a Neanderthal. Everything else would sweep back from the midline of your face. The brain case is quite different. We have relatively high and short brain cases. Neanderthals have relatively long low ones. And then, of course, you can see that in general, only modern humans have a chin. Now, I showed that slide because I wanted to give you just a taste of the fossil evidence for the origins of Homo sapiens. Now, as you saw on the last chart, and as I've already implied, Homo sapiens, our species, emerged in Africa. And it emerged at a time when there were only Neanderthals in Europe and only Homo erectus in the Far East. And how do we know that? It's certainly well before 50,000 years ago. Well, the evidence comes in two forms. The evidence for the emergence of Homo sapiens in Africa. There's fossil evidence, which frankly I think should always be paramount, but is today often taken secondary to the other kind of evidence, which is genetic. Here's some of the fossil evidence. This is a modern human skull that was, I call it modern, very robust, that was found in Ethiopia a few years ago. It's dated in publication about 160,000 years ago. Ka is thousands of years ago. I actually think it's probably somewhat more recent. But it's certainly somebody who was living in Ethiopia and Africa before 50,000 years ago, when there were only Neanderthals in Europe and only Homo erectus in the Far East. It's a particularly complete specimen, and you can see the characteristics identify it as anatomically modern. The shape of the brain case, which is relatively high and short, and even though it's very robust, with a pretty good sized brow ridge. The brow ridge actually differently constructed than in the Neanderthals, but still pretty big. I have a pretty big brow ridge, actually. Oh, not quite like this, but I can compare. Anyway, you can see that below the brow ridge, the face is nice and flat and short. This is somebody, again, we have other parts of the skeleton. You can put the flesh back on, put them in a fedora and a business suit. If they walked into the room right now, you might say, gee, that's somebody who's extraordinarily well built. And that'd probably be the only thing you'd notice, at least physically. Now, in terms of behavior, there might have been differences. The other source of information that we have indicates that modern humans originated in Africa, exclusively in Africa, while other kinds of people were occupying other parts of the world, Eurasia, is genetic, DNA. And this is a diagram showing the relationships among various kinds of living humans and the Neanderthals. And what you see Africans and non-Africans lumped together. It's Africans and some Africans, and all non-Africans are lumped together, very close together. And then you see two other groups of Africans. What it's telling you is that Africans are genetically remarkably diverse. Everybody else, in terms of their genes, is a kind of a subset of Africans. Eurasians are like Africans, but they're included within them genetically, and Africans are actually more diverse. Now, that degree of diversity of genetic capability in Africa implies that humans have been evolving, and modern humans have been evolving along with everywhere else, and that's how the variability managed to build up to the extent that it did. You see the Neanderthal there. It's a pretty amazing thing. I'm sure everybody's aware that we now have DNA out of Neanderthal bones. If somebody had told me when I was a graduate student, which was not long after the Neanderthals disappeared, somebody had told me that the Neanderthals would provide us with their DNA from their bones, I would have thought, well, that would be wonderful, but I doubt it. Well, there's no longer any cause for doubt. We have lots of Neanderthal DNA actually now, and we're getting DNA from yet other kinds of fossil people, including them. I think that we could probably label Homo erectus if we wanted to. And then you can see that the Neanderthal, if you're using the DNA, this is mitochondrial DNA to compare, different groups based on their similarities and differences. Neanderthals are way out there on their own. Obviously, a divergent evolutionary branch based on the mitochondrial DNA. So that's the last point here. So we have the genetics, we have the fossils to indicate that modern humans originated exclusively in Africa, and that while they were evolving in Africa, there were other kinds of people elsewhere in the world who, of course, no longer survive. Now, if modern humans appeared in Africa before 50,000 years ago, perhaps as much as 200,000 years ago, that's a debatable issue as far as I'm concerned, but certainly well before 50,000 years ago, why didn't they expand from Africa shortly after their appearance? People who look essentially as we do. Why were they confined to Africa for probably tens of thousands of years after they first appeared? Say they appeared 150,000 years ago, there'd be 100,000 years before they spread from Africa. The expansion from Africa occurred about 50,000 years ago. That's some very famous out of Africa event. So, the most obvious reason why modern humans didn't spread from Africa immediately after they appeared, at least anatomically modern humans, is because they were still behaviorally very much like the Neanderthals or like Homo erectus. And I just listed a bunch of ways in which they were similar to the Neanderthals in their behavior. They made a relatively small range of stone artifact types. Now here I'm talking about Africans who look very much like us, but who are behaving, to say, pretty much the same way as the Neanderthals. They made few, if any, tools out of bone or ivory or antler. They made artifact assemblages that persisted for amazingly long periods of time, thousands, tens of thousands of years, and over vast areas. When I first I did my PhD in Russia, when it was the Soviet Union, and I studied in Bordeaux to learn how to identify the different kinds of tools of the Neanderthals. Then I went off to Moscow and Leningrad, now of course St. Petersburg. And the tools that I saw there, the Neanderthal tools, we call them Mysterium tools, but they were made by Neanderthals in both places, say 50, 60, 70, 80,000 years ago, were very difficult to distinguish. Sometimes the raw materials would tell you you were in Russia rather than in France, but not the kinds of tools. When we get to the Cro-Magnons, after 50,000 years ago, it's very different. And the tools, when you're in Russia, are quite different in form than ones in France at any given period of time after 50,000 years ago. When you are digging a site that's older than 50,000 years, whether you're in Africa or in Europe, or I suppose in the Far East, although we know much less about the Far East, it doesn't really matter where you put a hole in the ground. You get the same stuff. These people didn't organize their campsites, in caves or campsites of some kind, or occasionally open air sites, in the way we do. So, you go out and you camp, you put your tent in one place, you clean your fish in another, you build your fire somewhere else. They seem to have done it all together. And so when you dig their sites, it doesn't really matter where you put the hole, you're going to get the same kind of thing. They also left us no evidence for housing of any kind. Now, they must have had housing of some sort, but it was too flimsy to leave an archaeological trace. They did bury their dead, at least I believe they did. There's some, I think, pretty incontrovertible evidence. There's particularly a Neanderthal burial from a place called Kabara in Israel, which I've always been convinced is a grave. And there probably are others that unfortunately weren't excavated carefully enough to document their graves, but almost certainly were more or less complete skeletons laid out. But in each case, and this is again a debatable issue, but as far as I'm concerned, there's no evidence for ritual or ceremony in the burials. In fact, in most cases, it looks like the people dug a hole just big enough to get somebody in, cover them up, and walk away. And you can even imagine that it was hygiene that was involved, not ceremony or ritual. If you want to continue to live in the cave, there's a dead person on the surface, what are you going to do? So you bury them, that at least gets them out of sight and out of the way. And then finally, two things that I wanted, the things that I boldface that I want to spend a little more time on. People before 50,000 years ago, and I'm talking about Neanderthals, but I'm also talking about people in Africa and in the Far East, rarely have ever produced art. This is debatable, but I'm going to expand on it a little bit while I say that. And then, before 50,000 years ago, it's very clear to me that people were not as efficient at extracting energy from nature and building it into people. No matter, again, where you were, Europe, Asia, or Africa. And one of the things that's really striking, it's only 50,000 years later that we get evidence for fishing, at least routine fishing, sure. Somebody might have walked along the beach and picked up a fish and brought it back to the site. They found a few fish bones in the site of Neanderthals or early anatomically modern humans of 60, 70,000 years ago. But routine fishing involving lots and lots of fish bones and also the technology for fishing only appears after 50,000 years. To me, this is a really important thing because if you're living out, in a place where there are fish, I work in South Africa, in South African coastal caves, you stand there and you see the fish offshore. If you can get those and you're a hunter-gatherer, forage, or whatever the proper term is, obviously you're going to build a lot, you're going to have a lot more energy to build into people, and there'll be more people. And in a sense, that's what evolution is all about, increasing human fitness, the ability to survive and reproduce, increase population size. Also, I think there's pretty good evidence that people before 50,000 years ago hunted less effectively than their successors. So if you're trying to understand, overall, why there wasn't any expansion out of Africa before 50,000 years ago, it's because people were still behaving in pretty much the same way in Africa as they were in Europe. They weren't fishing, they didn't make art, and so forth. That changed in 50,000 years. But just for the moment, I'm going to go through this quickly because I think we're short on time. There is, of course, there are arguments about art older than 50,000 years ago, and this is a problem because art is kind of like pornography. Everybody knows the judicial definition of pornography. When you see it, judges don't want to be much more precise than that. But art is kind of like that, isn't it? It's in the eye of the beholder. So if you really want Neanderthals to have art, you can find art. If you're really aggressive about it, and the same, of course, with early modern humans. So let me talk about that for a minute. There's a very famous site now called Bloembo's Cave in South Africa, dated to about 75,000 years ago. And it's provided a piece of red ironstone. You can see the scale on that. It's a very small piece. It's rectangular, it's maybe 2 to 2.5 inches long. And on one surface, there looks to be a bunch of X's in a frame. Now this is, let's say, 75,000 years old. So is this the world's oldest art? Abstract art? Well, I don't know. I'd be a lot more compelled to think of it as art if that were an outline of a human or an animal or something that was more readily recognizable as a creation of the human mind. This piece of ironstone, it's called ochre, comes from a site, Bloom's Cave, where there are more than 11,000 other pieces, sometimes with scratch marks in them, rarely with scratch marks, or in fact, none with scratch marks as organized as this. There are many other sites at the same age, I've dug some myself, that have provided tens of thousands of more pieces of this red pigment material, this ironstone. What were people collecting it for? The Neanderthals did as well, I might add. Well, we know that they used it as an ingredient. They would scrape powder from it, and that became an ingredient in the glue, the masking they used to stick stone bits onto wooden shafts. We have the stone artifacts with the ochre still preserved on the part of the tool that was stuck into a wooden shaft. So before they would get the powder off, they had to test the ochre to make sure that it was suitable, the powder would be suitable, and they often scratched it, they scraped it. Lots of pieces that are scraped, obviously, to get the powder. And if you have 11,000 pieces in one site and probably several 100,000 in others, what are the chances that one of them might come to look like this? If you're scraping over tens of thousands of years, hundreds of thousands of pieces. I always think about the old story, if you gave monkeys typewriters and enough time, they produce Hamlet. I think that's sort of what this is, but it's been regarded as art. It's sat for a long while and may still be at the entrance to the Houses of Parliament in Cape Town. And from the same site, there are these tiny shells, they're about the size of your thumbnail, from a creature called the tick shell. Grows on estuarine weeds, seaweed basically, which people have collected for a very long time. Stone Age people in South Africa for bedding, brought back to their sites and laid it down, and laid down on top of it. These things grow on that. This particular site has provided some 50 of these things. You can see there are holes through them. Those holes are not there in life. So how are they made? Well, there's no indication they're made with stone tools. They're through the thinnest part of the shell, and you could easily imagine that once they're in the site, people walking over the site, crushing everything below them. They did a lot of trampling, and they did all kinds of awful other things on the surface of their site that could produce these holes. If there were any evidence that they were artificially made, I might accept these things as what they're said to be here, beads. I'm not convinced. But if you want, again, say art, I'm taking jewelry to be art, is in the eye of the beholder, and if you want, you could make this art made 75,000 years ago. Then there are these pieces. This is probably the most convincing art in terms of its mode of expression. These are pieces of ostrich eggshell from a place called Deep Kloof Rock Shelter in South Africa. And they're in levels that are said to be 60,000 years old. Perhaps you can see the cross-hatching and so forth on these pieces. I have no question that that's somebody deliberately engraving on the ostrich eggshell. The problem is, and I should mention that at every site that we're talking about, my familiarity with it is from working with the animal remains. That's what I've done for many years. I've worked with the animal remains from all these sites, Bloom's Cave, Deep Kloof Rock Shelter, and others that I could talk about. And at Deep Kloof, which I'm very familiar with, in fact, just involved now in helping produce a monograph on it. This ostrich eggshell with the engravings is found about, let's say, 4 inches below the surface of the band. It's about 4 to 5 inches thick below the surface of the deposits that are dated to 60,000 years ago. Everybody except me says, okay, this means that these people were engraving ostrich eggshell. Historically, in the prehistory, we know that people engraved canteens. They made water canteens. So they put 2 holes in, a big one and a small one. And they would go and bury these things around the landscape so that if they were in immediate need of water and it was not available otherwise, they would go and dig them up. These people who did that were actually observed doing it, and we actually have some canteens from later sites. I kind of think that's what this is, except these things have been crushed and broken and stained, so they now look like they come from the deposits that are 60,000 years old. Anyway, but this, at least, is art. That in my particular eye, it looks like art. Now, we also have art, if you want to have art from the Neanderthals. I'll show you some pieces. There's a piece of schist that's been engraved there. That's from Bulgaria. there's a fossil, nummulite with a cross from Hungary. There's some shells from a place called Cueva Los Aviones in Spain, where the shells are perforated, and another site in Spain called Cueva Anton. These are Neanderthal sites that date from somewhere between 50 and 100,000 years ago. There's some pierced shells from Cueva Anton, and they're covered, this one is covered with pigment that the Neanderthals had brought back there. Maybe this was some kind of painting tray, you can argue. In fact, the person who found it, pushed it, says that's what he thinks it was. If we thought that the Neanderthals could be our ancestors, if we had fossil and genetic evidence to make the Neanderthals our ancestors, I have no question this stuff would be considered art. But since it's pretty clear that they did not give rise to later people and did not give rise to the higher levels of civilization that later people created, we tend to discount this and only look at the African stuff as art. So art becomes common in Africa and Europe only after about 50 to 40,000 years ago. The oldest art that I would accept, again, taking jewelry to be art, are ostrich egg shell beads. You see one there, surrounded by two pieces of ostrich egg shell that were beads in the making. When you make ostrich egg shell beads, and people were still doing this historically, you make the hole in the ostrich egg shell first, and then cut out around it. And you get these donut-shaped things. There were 13 from this site. It's a site called Nkapune Amuto in the Central Rift Valley of Kenya, and they're dated to around 45,000 years ago. Now, unlike those tick shell things we looked at a moment ago, there's no question but that these were humanly manufactured, humanly shaped. And then, of course, when we get to Europe, Europe has been much more prolific in providing us with ancient examples of art, mainly because there are more archaeologists there and maybe a larger number of appropriate sites at the right age. But we get these fantastic figurines. There's a Venus figurine, so-called, dated from somewhere before 35,000 years ago, probably closer to 40, from Germany. And then, of course, we have the famous wall art, which is at least, in this cave, Chauvet Cave, 32,000 years ago, 32,000 years old. Some of the black pieces is carbon. You can scrape off a tiny little bit of it, and it can be radiocarbon dated. So we're not just guessing about the age of this stuff. Now, everything on the screen here, I think people will agree is art, unequivocally art. The stuff before, whether it's from the Neanderthal sites or from early modern human sites in Africa, we can argue about. Now, what happened that promoted the out-of-Africa expansion 50,000 years ago is that we got a very radical change in behavior. This change is said by archaeologists to mark the transition from the Middle Stone Age, abbreviated MSA, to the later Stone Age afterwards. Change from the Middle Stone Age before 50,000 to the later Stone Age after 50,000. And I've talked about art. Art, of course, appears in these later Stone Age sites. But there are lots of other differences between later Stone Age sites, one post-dating 50,000 earlier sites. Later Stone Age sites, the earliest, to provide undoubted evidence for the bow and arrow. Now, there's just an article in Nature this past week arguing maybe that the bow and arrow was present 70,000 years ago. That article is based on artifacts that look like these things here. These are pieces where one edge has been dulled or backed. They're roughly, they vary between 1.5 and 2 inches long. They look to me like they're a little big for arrowheads. Been argued for years that they were, then the argument goes away and now it's back again. Up here, you have pieces that are very similar in shape, but tiny, much smaller. Those were arrow armatures. And we actually have some of them still mounted in little balls of glue, of mastic, on the ends of wood or reed shafts in fairly recent sites where there's excellent bone preservation. We know those things were arrow armatures. So you can see there's a tremendous difference in size. The shape is similar, but there's a tremendous difference in size between these at the top and these at the bottom. These are later Stone Age ones here, I should say, at the top. And these are Middle Stone Age ones here at the bottom. LSA and MSA. And then in the later Stone Age, we get the first ornaments, like those beads that you looked at. We get a lot of ornaments made, we think they're ornaments made in bone and shell. You see some here. And we get wonderful bone artifacts of various kinds. Awls, projectile points probably. These things are probably projectile points. Bone projectile points have a particular advantage because they're light, they can be shaped, they're more aerodynamic than stone ones can be. And we know historically, ethno-historically, people were using things like this for arrow points. Here you have some interesting things. These are double-pointed toothpick-like things, and they're about the size of a toothpick, that we know historically, ethno-historically, were used for fishing. Tie them to a string, put some bait out, toss it out, and bring the fish in. Those ones you're looking at there, though, are about 13,000 or 14,000 years old. Okay. So if you look at animal remains from various sites in Africa, and actually in Europe as well, but I'm focusing on Africa here, it's pretty clear that people before 50,000 years ago did not hunt and gather as effectively as people afterwards. And I'll go through this. I'm not going to read these things off because I don't think there's time. There are a couple at the bottom that I really want to emphasize here. Sites before 50,000 years ago, ones that are called Middle Stone Age, contain very, very few fish bones. I've already talked about that. They're so rare that you would easily imagine they're just a result of beachcombing, not regular fishing. And also, sites that are older than 50,000 years. Now, we're talking about Africa here because that's the place in which the modern human expansion occurred, and I'm trying to explain why I think it only occurred 50,000 years ago. In sites that are older than 50,000 years, we get lots of shellfish. People were collecting shells. They've been doing that for a very long time, probably since they lived at the coast, maybe hundreds of thousands of years, although we don't have any evidence before about 150,000, but they've probably been doing it for a very long time. And they also collected tortoises, which are very common in African environments, including near the tip of Africa where I live. If you think of yourself as a shellfish or a tortoise collector, and it's brunch on Sunday, and you got to go out and get some stuff for the people you've invited over, tortoises and shellfish are particularly easy to get. No technology involved in collecting them, no risk, no personal risk. You can just walk out of your cave if you're in the right place on the coast. You can just get them. There they are. They wouldn't sustain you for forever. You'd probably also want to hunt wildebeest every once in a while and so forth. But for a meal or two, or for a supplement, most meals they'd be fine. Now, if you do this, if you walk out of your site and you look for shellfish on the rocks offshore, or you look for tortoises in the surrounding bush, which ones are you going to pick up first? The big ones, the biggest ones, for two reasons. First of all, because they're the most visible, and secondly, because they have the most flesh, the most food return. So if there are a lot of people doing that, what's going to happen to the average size of the shellfish and the tortoises? It's going to be driven down. And this is what we see. This is the point. I get a little bit ahead here so that I don't overstay my time, if I can say this now. Before 50,000 years ago, shellfish and tortoises are huge in Middle Stone Age sites. Afterwards, they become much smaller. To me, what that's saying is that human populations have increased substantially beginning about 50,000 years ago. And they've driven down the size of the shellfish and the tortoises because there are now more people pressing on them. For time here. Let me go very quickly. I thought you might be interested in seeing pictures of some of the sites that are providing this information in South Africa about the change in human ability to forage to hunt and gather 50,000 years ago. Most of them are within that rectangle there around Cape Town, but there are a couple further out on the Indian Ocean coast. See if I can find the pointer. I should try and make it bigger, but maybe you can see. I saw it for a second there. If you look out maybe an inch to the right of that rectangle, you can see Blumbo's Cave. There are a couple other sites that go further out than that that are important. Within the rectangle, there are some very important sites. Kelder's Cave, which I don't have time to talk about, but you can see if you look further up, you'll see the deep blue shelter. It's bold-faced for you there. And then there's a site, I wish I could find the pointer. It's very small, and I am very, very, oh, there it is, there it is. There's a site there called Easterfontein, which I've been excavating until very recently, which is relevant to this whole issue. These are sites, the ones that are bold-faced are Middle Stone Age sites, the ones that are not bold-faced are later Stone Age sites, and they're the ones that show us this difference in hunting and gathering efficiency between Middle Stone Age and later Stone Age people. So here's Blumbo's Cave. I won't say very much about it, because there's not a whole lot of time. Very picturesque place on the Indian Ocean, about 275 kilometers east of Cape Town, excavated by Chris Centralwood from the University of the Witwatersrand. Here's the Easterfontein site, where I worked for many years. You can see here it's in a village, actually. It's like a holiday community. This isn't hardship work. No hyenas and lions in the street. We rented houses here and lived very, very comfortably. The site, which is right here, I will be able to find the pointer again now. You see where it says diorite concrete interface in the middle of the picture on the bottom left. There was a cave here, and it collapsed. And it was when they were widening the access road to the parking lot, you can see there, they cut into it, and artifacts and bones and shells and so forth began falling out. And so we, colleagues of mine from the University of Cape Town, the South African Museum, and then from a couple different American universities, decided to do an excavation, and we found it was a collapsed cave full of nicely stratified materials, like fireplaces and all the rest of it. There's the Deep Kloof rock shelter perched on top of a granite hill, and you see it's pretty spectacular. This is now north of Cape Town, about 150 kilometers. So we started Bloomos on the Indian Ocean coast. We've now moved to the Atlantic coast. Oh, this is a little ways inland. And you can see it in excavation, pretty big excavation. You can see there's cutting through the deposits, and you see the fireplaces, the ancient the ash and charcoal and so forth that are giving it that striking. Now, I mentioned that on both coasts, or maybe I didn't say both coasts, but I should say both the Indian Ocean and the Atlantic coast, the tortoises and shellfish are much larger in Middle Stone Age sites than they are in later Stone Age sites. And I stress the difference between the coasts because they're quite different. The west coast is where the waters are very cold. The adjacent land actually is not particularly productive because it doesn't get much rain. The south coast, the waters are much warmer. The adjacent land gets more rain. It's much more productive. The species that you find of shellfish in particular are very different between the two coasts. And yet, in spite of the difference in species between the two coasts, they're always bigger in the Middle Stone Age than in the later Stone Age. This is just showing you the tortoise thing. These are later Stone Age tortoises here. The line near the middle is the median size. And then the gray bar around the line is an indication of the likelihood that we've estimated the size with some probability. Gray bars that don't overlap between boxes indicate that the average size, the median size of the tortoises is significantly different between different samples. You can see that in general, the Middle Stone Age ones are significantly larger than the later Stone Age ones. And then it's easier to do this with the shellfish because the thing that I measured to do it is much bigger, whereas shells. This is the trapdoor, if you like, of a snail-like animal that lives on the south coast of South Africa. And you can see there actually is variation within the later Stone Age in its size. It gets smaller over that way, bigger over that way. But then when you get down to the Middle Stone Age, they're always much bigger. They're varying in both the Middle Stone Age and the later Stone Age, but the envelope within which they vary is an envelope that's much to the right on a slide like this in the Middle Stone Age compared to the later Stone Age. And I've highlighted here the Bloomos cave levels that have provided this thing. You see this is the trap door of this animal. And you can see that they're very large. Those shellfish, those trapdoor things called percula are very, very large. So if whatever the people in Bloomos cave were doing, if they were making art, if they were behaving in all kinds of other modern ways, which I am very dubious of, it didn't seem to increase their population numbers. At least if you think that large shells mean sparse human populations, which I do. So, human ability to survive and reproduce increased dramatically about 50,000 years ago. And this is what I think precipitated the out-of-Africa expansion. Well, what are explanations for this increasing human fitness, ability to survive and reproduce? The most popular one, I think, and certainly thinking just about people that I know who I'm in contact with on a regular basis, my colleagues who work on the same issue, the most popular idea is that there was population growth in Africa between, let's say, 100 or maybe even 150,000 years ago and 50,000 years ago. This was now among people who already were anatomically very much like this. And that this led to socioeconomic reorganization, perhaps the development of the nuclear family, division of labor by sex and age, and so forth. And that at 50,000 years ago, a kind of transition was crossed, and now we have fully modern people. And the reason they're fully modern and began doing things in a fully modern way is because they had fully modern social organization organized to provide, to innovate, come up with new technologies as a result of the change in population growth or population size. Now, I don't know whether that makes any sense to you, the population growth thing. It never made a lot of sense to me. First of all, you have to explain why the population is growing. There's always, of course, the potential for human population to grow. The Australopiths of 4 million years ago could have overrun the planet with no problem whatsoever if they'd been allowed to reproduce and if their offspring could have reproduced without any problem. The intrinsic reproduction rate is more than adequate for humans, even as much as 3 or 4 million years ago, to outrun their resource base very quickly. And the same would have been true right through time. I don't see why between 150 or 100,000 years ago and 50,000 years ago, human population would suddenly begin to grow. But the fact is, we have evidence that they didn't. And it's not just the shellfish that I was talking about before, which suggests that human populations were pretty sparse in the Pacific. When you get to about 60,000 years ago in southern Africa, between 60,000 and 30,000 years ago, we can't find people. The archaeological sites we have, we usually have a break. It'll be the Middle Stone Age layers that are older than 60, and then later Stone Age layers that are younger than 25 or 30, and nothing in between. And we know that it got very dry, and as a result of getting very dry in the middle of the last glacial period, the animal and plant populations crashed, and so did human populations. But the point here, the bottom line, is that human populations were not increasing toward 50,000 years ago. If anything, they were declining. So what's an alternative? Well, here's one that I'm accused of pushing all the time. And that is that there was a genetic mutation roughly 60, maybe 70 to 50,000 years ago, and this promoted the fully modern human ability to innovate, to manipulate culture, or, manipulate culture as we understand by now, to run this vast array of software programs that the human hardware, sort of, that's also a sort of software too, allows, the human brain allows. And I'm saying, I think the brain has allowed that proliferation of cultures only appeared about 60,000 years ago, and underneath that, behind that, was genetic change. Pardon me. How can you test an idea like that? Neanderthal skulls won't help you. I mean, they're as big as ours, they're different in shape, but we don't know the difference in shape. It's telling us anything about a difference in intellectual capacity. So there's nothing in fossils. There's nothing in the bone part of fossils, the morphology, that will allow you to say that one group of people were genetically more intellectual than another. But we now have the Neanderthal genome. And this, I think, provides a possible way of getting at this issue. You've probably read about the Neanderthal genome. It suggests that Neanderthals and modern humans may have been bred, and that Neanderthals contributed as much as 2.5% of modern human DNA. Walking around with that much. I'm dubious about it. I think they probably didn't agree. I mean, modern human males won't agree with just about anything, won't they? So it seems very likely that Neanderthals and modern humans given the opportunity, would have bred Neanderthal females on occasion. Whether that number is realistic or not, I don't know. What seems to me to be more interesting is that the genome as it's developed so far suggests that we have genes that are derived relative to what the Neanderthal, to some Neanderthal genes. Neanderthal genes, in other words, are, in some respects, more like chimpanzees. No, they're not chimpanzees, but that they're more primitive than, they have genes that are more primitive than ours in the direction of chimpanzees. And there are some of these genes that we have that are more derived than in Neanderthals that do bear on cognition and communication. Now, I don't want to push this too hard, because if you look at this chart closely, you'll see that they're in the box there, the yellow box. They're genes that are implicated in autism, schizophrenia, and so forth. And while they are behaviorally relevant, I didn't want to imply that the Neanderthals were all autistic and schizophrenic. I don't doubt that seriously. But I think at least this raises the possibility of identifying genes. Once we have the complete genome of the Neanderthals, and we have it in multiple forms, lots of coverage, of looking for genes that do bear on cognition and communication, that the Neanderthals, I'll put it simplistically, lacked and that we have. And then the next thing would be to show that those genes were swept by selection to fixation about 50 to 60,000 years ago. So this is a testable hypothesis in theory. The biggest problem, if there is one, is that the gene, if there is a gene or genes that were responsible for the modern human brain, in the sense that I'm talking about, and that only appeared 50, 60, 70,000 years ago, they might have been regulatory genes, genes that switch others on and off. And those will be very difficult to find, no matter how complete the Neanderthal genome becomes. So, that's my idea. It's the only way I see it tested. I know it may sound implausible that genetic change can underlie the out-of-Africa expansion, but I just don't see that the alternatives are more plausible. They're in some ways psychologically more satisfying. Then we don't have to worry about finding Neanderthal tomorrow, whether we let them in Harvard or not. But I think that they're no more, in terms of the archaeological and fossil evidence, they're no more satisfying than the genetic. Okay, I may have already overstayed my time. I'd be happy to try and answer any questions if there are.
In the South African sites, when you look at the Middle Stone Age versus the later Stone Age sites, is there a difference in the skeletal robusticity of the hominids that you find there?
Well, there's a difference in the skeletons. Let's put it skeletal remains in general. I mean, this is something, we talk about these people as anatomically modern. People lived in Southern Africa between, let's say, Africa in general, between, let's say, 150 and 1,000 and 50,000 years ago. There are people who emerged from Africa briefly into what is now Israel about 110,000 years ago. Famous people from places like School and Kafsa Cave. We also call them anatomically modern. They were Africans who just managed to make a little bit out of Africa when Africa expanded a bit ecologically. But look at those fossils. Are they modern? I've been pretending here as if they are. I'm following the conventional line that these are people who, again, look just like us and just behave differently than us. I don't think they look just like us. They just weren't, they're more like us. They derived in our direction away from the Neanderthals. They're more like us than the Neanderthals are. So we call them modern. At the Klassisch River site, which I didn't mention here, but it's a very famous Middle Stone Age site, there are a lot of fragmentary human fossils. They look modern in general. I mean, they have chins and things of that sort. But the size variation is so incredible that it's hard to imagine it's one population. There's the smallest human jaw I've ever seen, and then there are jaws that are bigger than the average for modern humans. Is it sexual dimorphism? The small ones are female and the large ones are male? Maybe. But if that's true, there's no modern human population that shows that degree of sexual dimorphism. So what is it? Could it be two species? I kind of doubt that. But whatever it is, it's indicating that these people who were living at Klassisch River, let's say 70, 80, 100,000 years ago, were not modern anatomically in the sense that we are. And I think we make the same case for some of these other African fossils. Well, so I think there was still some skeletal change to come too.
But is it possible that the Middle Stone Age people, or hominids, were able to get bigger tortoises and bigger shellfish because they were stronger physically, and the later Stone Age hominids, being less robust and physically weaker, could only handle smaller?
No, I mean, when you go out to get tortoises, I've done this. Tortoises, my wife has done it. Tortoises and shellfish don't require, the kids do it. I mean, there's nothing, and in fact, you know, hoping to sound sexist about it, it's mainly something women and children do. It doesn't require any special bodily strength. It requires no technology. Not only do humans of all kinds, both sexes and tiny children do it, a lot of other species do it too, routinely. It's been said that it's been written that somehow shellfish collecting is at the root of modern human origins, modern human behavior, because some of the oldest evidence we have for modern humans is in southern Africa, and they were, living in sites where they were collecting shellfish. But baboons collect shellfish. Yeah, I mean, baboons at Cape Point, just south of Cape Town, collect shellfish routinely. Seagulls collect shellfish, and they're pretty clever. They pick up things, these mussels that are still enclosed in hard shell, and they'll fly up in the air 30, 40 feet and drop them on a hard surface, crack the shell, so they can get the flesh. And when they do this routinely, they build up things that look like human shellmates. So shellfishing in and of itself, I don't think is anything very special. I don't think it requires any special intellect, any special body form, or anything of that sort. It does help if you know something about the tide tables. The first site I excavated in South Africa 40 years ago, I would go down on the rocks at lunchtime, right on the rocks, and see what there was, and try not to disturb things too much. But sometimes the tide was coming in, then I didn't do it. Wouldn't be a good idea, right? But I could see that from the shore. I wasn't reading the tide table every day, but I could see when that would be safe and when it wouldn't be. And I'm sure the baboons can do it, so presumably Stone Age people can do it. Yes.
Hi. Two questions. The issue of similarities between Neanderthal brains and modern autistic brains, and various people have looked into this. One of the things that autistic people have difficulties doing is not necessarily innovating, but making connections with other human beings. That is, building and believing in culture. And maybe even building on the intersubjective, that is, understanding others. And I was wondering if that's at the root of innovation. The other thing I wanted to ask is, are your fellow South African paleoanthropologists, do they look at you askance? Because it seems to me that they're mightily trying to show that modern human behavior does extend back to 100,000 years ago. Just recently, a discovery of continuity blade technology going back 90,000 years. Are you pissing them off?
I mean, you know, it does become a highly personal thing. There are people who I work with there. They all come to me when they have animal remains that need to be analyzed. It's not a particularly, it's not a skill that's in high demand worldwide, but it takes a little while to get it. And so if you want somebody to study your animal bones and your shells, and you want somebody who I think does it in a reasonable way, accurately, to come to me. So these people, even if they might disagree with me about the origins of modern humans, the behavioral implications of things that are 70,000 years old, they still give me their animal remains, and that means we have to interact. And I think we do it fruitfully. I mean, there's nobody that I can think of there with whom I have an antagonistic relationship, even though we disagree pretty strongly about the meaning of some of these so-called early art objects and so forth. And just today, I maybe have come a little closer than most of you. I could check my email at home today, and then drive in. It takes about an hour. And I had an email from somebody, the excavator at Robo's Cave, and we're discussing some of the issues of the origins of modern humans, the dates, and all that kind of stuff, without any entity whatsoever. So that works out pretty well. There is a problem that, of course, if you're an archaeologist and maybe a true or anybody else, and you want to get a little publicity for your work, you have to somehow argue that it's unique. If you're an archaeologist, maybe it's the oldest example of this, or the most spectacular, and it's a natural inclination to do that. And then people who are doubtful, if they happen to say in a newspaper article that they don't accept that, that can be a little bit of a problem. I'm sorry, I forgot your first question.
The first question was about autism, and this genetic change you're suggesting takes place around 60,000, 50,000 years ago, and you identified it as a modern ability to innovate. And I was suggesting that it is perhaps the innovation actually stems from a greater sense of groupness among human beings, a greater sense of being able to not only understand oneself but others, and so pooling intellectual resources, so to speak.
Yeah, I mean, it's possible. I wouldn't object to that. And in terms of the population size thing, the population density thing, obviously, the larger a population, the more likely it is that they'll contain innovators, and the more likely that the innovations will be retained and not lost by chance. So maybe the problem the Neanderthals had, they were perfectly good innovators, just weren't enough of them to, enough innovators around, because there weren't enough Neanderthals to make the kind of cascade of innovations that would have been necessary to make the everyday living. And maybe when they did come up with something interesting, because there were for many of them, it was often lost. They did some pretty spectacular stuff, I should say. I've been accused of being a Neanderthal basher, but there are several sites in Europe where it's now clear that they were able to extract pitch, the tar from birch bark, which requires a very sophisticated use of fire for regulating the temperature. They wanted this, of course, to mount stone artifacts on wooden shafts. It's pretty smart. There's nobody in Africa before 50,000 years ago who did anything that required any more ingenuity than that. And they did other things too. I think, indicate that intellectually they were at least the equivalent of people in Africa before 50,000 years ago. And if things had turned out a little differently, maybe if you take my perspective on this, a mutation that provides the modern human brain, it could happen among Neanderthals, in which case we'd be in this room today talking about the strange people who used to live in Africa.
I have two questions. One is about the date of 50,000 for Homo erectus in Asia. That's a little bit later than the dates I usually see. So I wondered if you could say something about that.
Well, there are two. To my mind, there are two versions of Homo erectus. This was the original position. I mean, Franz Weidenreich, who studied the Indonesian fossils, the Javan ones, who studied the Chinese ones, and Ralph van Keningthal, who studied the Indonesian ones, initially separated them, as other people did, between Peking man and Java man, which they gave different species names to, and then they got together and decided they were one thing. Bill Howells at Harvard in 1950 decided they were one thing, and he had enormous influence, and we've called them Homo erectus both all since then. I think they're two things, and one of the reasons I think they're two things is because it looks to me like they're different evolutionary trajectories. In Indonesia, you end up with something, whether it's 50,000 years old or not, I don't know, but arguably it is, that still looks like Homo erectus, like classic Homo erectus. A little bigger brain, but in terms of skull shape and so forth. Classic Homo erectus at 50,000 years. China, no. In China, about 200,000 years ago, you're dealing with people who are not Homo erectus in any kind of classic morphological sense. They're not modern humans either, but they tend to have some modern human features. In fact, Chinese scholars like to emphasize those flat faces underneath relatively short skulls, not much in the way of forehead, big brow ridges, other features which indicate that they're not modern. But the fact that the people who appear in China 200,000 years or later are quite different than those who lived in Indonesia at the same time, assuming that in both places they're derived from what was called Homo erectus earlier on, that would imply two different evolutionary pathways. Now, how long they lasted, I mean, I take 50,000 years simply because that's the time of the out-of-Africa expansion and the more or less the time, maybe a little later, for the disappearance of the Neanderthals. But what we know so little about the Far East. We do know, one thing we know, is everybody who lives in the Far East today is walking around with genes that came from Africa in the last 50,000 years or so. That's clear. But what happened to the people who were there before them, that's not so clear, when they actually disappeared.
And my second question was, when you had the diagram about, the genetic diagram about Africans in 92 and 191, who are the Africans who are more different from other Africans than everybody else?
Oh, well, that's a good question, and I don't have the detail. I mean, I have it, I can get it on my computer.
Are they San-speaking people, or?
Oh, well, yes, definitely. I mean, the 9 that were way out there at the bottom, those are all Khoisan people. All San people. But the others, yeah, I mean, the deepest genetic lineages in Africa today are in southern Africa, among people who live in the Kalahari Desert, particularly mitochondrial lineages. And they stand out pretty clearly from other people. But then Africa is genetically complicated. I mean, there's been a lot of population movement, replacement, whatever. So I'd have to look. I mean, the people who've did the study from which I drew that chart actually have a much more detailed chart with a bar for each group that's involved.
Two questions. Is there anything, you say anything about the transition to the anatomically modern Homo in southern Africa or elsewhere? I mean, you had moved from Heidelbergensis to them. Do we know anything about how that transition occurred or any forms? And the second is, do you think there's any way to comment on the Tattersall's idea that it was the cultural evolution of language that was responsible for this lab?
Yeah, I mean, we don't know. When you start talking about transitions, it's easy enough to gloss and say, well, Homo heidelbergensis is this thing that's a common species to Africa and Europe that was ancestral to the Neanderthals in Europe and modern humans in Africa. But specimens that actually document that in a compelling way, I don't know. I mean, I wouldn't want to try and say that.
What's the gap between the latest Heidelbergensis and the first anatomically modern? How long a period is blank?
Well, the record's very sparse. I mean, we have Homo ergaster in Africa for sure, up to 900, what I call ergaster, other people call Africa Homo erectus, up to say 900,000 years ago for sure. And then I would say there are some younger fossils going as recently as 600 or 700,000 years ago. You could still call ergaster things from North Africa in particular. And then, what about Heidelbergensis? Well, there are maybe 4 or 5 Heidelbergensis skulls from both Africa and Europe. The most famous one in Africa is from a place called Broken Hill or Kabwe in Zambia. I say it's 400,000 or 500,000 years old, but boy, I would be really hard pressed to support that with anything but its morphology. I mean, the record is very sparse. There are very few Heidelbergensis skulls, 2 or 3 in Europe, 2 or 3 in Africa, and their dates are hardly secure. So if you're talking about a human evolutionary tree that's a hypothesis, that's a big part of the hypothesis right there. It requires a lot more data before we can say that we moved ahead on it. These fossils are so hard to come up with.
Anything about language, or is that just...
Well, the language thing, I've always thought that language could be what underlies the modern expansion, and that if there was a neurological change, it might have been a change that promoted fully rapidly spoken phonemic speech, like I put out. I think that's a reasonable idea. There's interesting linguistic evidence on the spread from Africa. There's a person who works in New Zealand, a linguist that named Atkinson. Some of you I don't know him, but he looked at phonemic diversity In fact, they found that it declined with distance from East Africa, which is also true of genetic diversity, which is one of the arguments for African expansion. But in terms of, and that could imply, if that's true, that might imply that the people who left Africa left with a single language. Doesn't tell you that there wasn't language before that, but it would tell you that whatever it was 50,000 years ago, there was just one, and everything else is derived from it. I don't think it's a popular idea among linguists. I don't think they think there's a lot of evidence for that. Well, I appreciate your patience. Thank you very much.